for today, we're going to go back and we're going to look at our day one notes and we're just going to finish this. And what we're going to do is we're going to check our homework at the same time. We're just going to keep alternating, okay? So, last time we started this 4th root of 256, x to the 21st power, y to the 30th power, but we didn't finish. All right. So, this root of 4 tells me that I need 4 the same in the group in order for it to come out of the radical, yes? But whenever I have numbers, guys, the first thing I'm going to do is I'm going to put it into the calculator and see if I get a non-decimal number. If I do, then that's it. If I get a decimal, then I have to do it the long way. Does that make sense? Okay, so I'm going to put a little answer box over here. 4th root of 256. If you put that into the calculator, what do you get? Do you get a nice pretty number, or do you get a decimal? Do we remember how to put in the 4th root?
Go to math.
So you have to go to 4. You have to type in 4 first, and then go to math.
And then 5.
And then 5. You got to type in the one with the little x in front of the radical. Okay, so let's all try this. Some of your calculators are fancy, and the 4 will jump right into the x. Some of yours looks like mine, and that's okay. Just have the 4, and you put the little x. Do you need a calculator? All right, so the 4th root of 256 should give me 4. There's no decimal, so I don't have to do this the long way. So that's just 4. Okay, so the 4 comes out. Now, guys, let's look at x to the 21st power. Remember, power over root. So this is really x to the 21st over 4. X to the 21st over 4 power, right? So, okay, if I put in 21 divided by 4 into my calculator, I get a decimal, right? So you have a couple of options here. You can draw out 21 x's, okay? Which you can do on the SOLs because you have all day to take them, right? But since we're in class right now and, you know, I don't want to draw out 21 x's, I'm going to show you another way, all right? So what you would do is you would just do regular long division, right? 21 divided by 4, okay? All right, so your calculator will tell you how many groups of x's come out. If you put in 21 divided by 4, what's the decimal that you get?
5.25.
5.25. So that 5, that number goes here. That's your outside number. Okay, that whole number that comes out, that's what goes there. So what is 5 times 4?
20.
Okay, so then just subtract that out of the 21, and how many do you have left? 1. So you know what? This number is how many come out, and this number is how many have to stay inside. Does that make sense? So what you would have is out is x to the what? 5th. And then let's leave some room. We'll put a 4th root. X. How many x's stay in? Just the 1, right? Okay. So that's another way to do this if you don't want to draw it all out. Now let's look at the 30. Y to the 30th power. 30 over 4, right? Put in 30 over 4. Tell me if you get a decimal or a non-decimal.
7.5.
7.5? Okay, so that means I'm going to do it this long division way again. Timwin said it's 7.5, so that means 7 is going to be my out number, right? What is 7 times 4? 28. So subtract that from 30, and what do you get?
2.
2. Well, that's your remainder. And that's your inside number, right? Okay, so let's see. That means y, I have 4 that come out, y to the 4th. And I have 2 that stay in. And there you go. That's how you do that one. Okay? All right, so I want to look at the homework. Let's check the homework together for sheet A. So 1 through 4, let's say give you the answers to number 4, and I want you to check. And if you got any of these wrong, then please say something and we'll go over it, okay? Number 1 and 2, you were supposed to rewrite it using the radical. Fifth root of x squared, yes? All right, number 2 should have been 4th root of 10. Good. Number 3, you have x to the 4 halves, which don't leave it as 4 over 2, because what's 4 over 2? What does that simplify to? 4 divided by 2. So this would be x squared. Now look at number 4. What did you get for number 4? Y to the, what's the power on the y? 10. What's the root? Okay, can you simplify 10 over 4? Put that in the calculator and hit math, enter, enter. What do you get? Okay, now hit math and hit enter, enter. Good. 5 over 2. 5 halves. Good. Yes. All right, so number 5. How many of you guys did number 5? Okay, let's do number 5 and 6 right now, please.
I have number 5 and number 6.
Good. So let's do this. How about we do number 5 together, and then you do number 6? Because I see some of you guys look a little bit confused. If you're already working on number 5, then great. Okay? So let's do 5 together. So I'm going to put my answer down here, okay? When I start doing this, I'm going to do just the number first, okay? So cube root of 8. Put it in the calculator. See if it gives you a non-decimal, pretty nice number. Cube root of 8. Where do you go to get the cube root? You go to math. You see the cube root? 4? Huh? Yeah, what's the cube root of 8? 2. Good. Alright, so that's 2. Since it's just a plain old 2, that means that just comes out. There's nothing left over. Now I'm going to look at my x's. How many x's do I have? 3. How many do I need in the group to come out? 3. Well, alright, so then that's x, x, x. I have a group of 3. There you go. Or is power over root. What's 3 over 3? 1. Okay? So that means one group of x's comes out. Nothing stays inside the radical. Are we okay with that? Alright, so now let's look at my y's. How many y's do I have? Just the 1, right?
Yeah.
How many do I need in the group to come out?
3.
3. Do I have enough? No, there's not enough, so it has to stay inside. Okay? Now look at the z. How many z's do I have? 1. How many do I need in the group to come out?
3.
3. Do I have enough? No, so that stays inside. So that's the answer to number 5. Are we okay with that? Tom, did you get that? Good. Huh? If it doesn't have enough to come out, or you had like one group of 3 and then you had like one left over. The leftovers go in the box, this box, right? Okay? Any leftovers or anything that doesn't quite make that group, okay? So let's try number 6. Look at number 6. How many do you need in a group to come out? 4. Okay, so go and look at the X's, go look at the Y's, and go look at the Z's, and see how many groups of 4 you can make. Okay? The groups, they come out. Only one from the group comes out. Any leftovers have to stay inside the 4th group. All right? So try that. All right, number 6. Remember, the root tells me how many I need in a group in order to come out of the radical. So let's see. There's no number. So, all right, I'm gonna look at my variables. Now, starting with the x's. X's power over root. Do I even have enough to get a group of 4? No, I only have 3. So, stays inside. It's got to go right back inside. Okay? Now, let's look at the y's. Y to the 5 over 4. Well, 5 over 4, it won't simplify to like a nice non-decimal number, right? But let me think. If I have 5 y's, how many groups of 4 can I make?
1.
Just 1, right? Because 1, 2, 3, 4, 5. I have 1 group. How many do I have left over? 1. So 1 comes out. And then, because the group, right? The 1 from the group comes out. And then the 1 that was left over stays inside. Right? So then let's look at the z's. Z, how many z's do I have?
8.
8. And the root is 4, so wait a minute. If I think about this, hold on. 8 divided by 4 is what? 2. So if I wrote it as power over root, then that gives me 2. Then I could go, all right, well then that simplifies to z squared. Think about it in like, the groups. If I have 8 z's, how many groups of 4 can I make? 2. Do I have any left over? No. So this is the, yeah? Does this make sense? So, I mean, you could even just write it all out if you wanted to. 4, 5, 6, 7, 8. There's 1, and here's another one, right? It's 2 perfect groups. Any questions about that? Okay. All right, perfect. So, can we try another one? Let's try 7 and 8. So 8 is a little bit tricky. So we'll do 8 together, but I want you guys to try number 7, please. 4th root of 256, xy to the 4th. You guys can definitely do this one on your own. Yes. Okay, so number 7, remember, we're looking at the root. The root is 4. That tells me I need 4 in the group in order to be able to come out of the radical, okay? So I'm always going to start with the number, if there is a number. So 256. What is the 4th root of 256? It's 4. Good. The first thing you want to do is just put it in the calculator and see if it gives you a nice non-decimal number. If it gives you a decimal, then we have to do it the long way, okay? All right, so that's 4. Do we know how to put in the 4th root of 256? Are we okay with that? Okay. So 4 comes out, and we're good. Now, let's look at the variables. Look at your x. X. What is the power on that x? 1. Right? What is the exponent on this? 1. Right? What is the root?
4.
4. Okay, 1 over 4, I can't simplify and get a nice, pretty whole number, right? So I'm going to go and I'm going to think about this. If I have 1x, can I get a group of 4? No, you don't have enough. So it has to stay inside. Okay? Now look at your y's. How many y's do you have?
4.
Good, that's the power, right? What's the root? 4. What's 4 over 4? 1. So this is y. Since it's just a nice, pretty number 1, that one just comes out. Or you can think about it this way, Ethan. You think of it like this. You have 4 y's inside. I need groups of 4 in order to come out. So perfect. 1 group of y's with nothing left over. Okay? So the answer for number 7 would be 4y times the 4th root of x. Yes? Okay. So let's look at number 8 together. So 8, I have the 5th root of negative 324 x to the 16, y to the 4th. Okay. So starting with the number here. Guys, let's put this in the calculator and see if we get a nice pretty number. So the 5th root of negative 324. All right. So 5, because I want the 5th root. And then I'm going to go to math. And that's the 5th one, right? With the little x in front of the radical. What is it? Negative 324? You get decimal? Oh no. That means we got to break it down. You have to do this one the long way. Alright. So let's do it. 5th root. So if we have a negative inside, that means that if we bring out anything, then the negative has to come out. Okay? So just for now, I'm going to ignore the negative. I'm just going to break down 324. Okay? I know it's negative. I'm just going to ignore it for a second. So 324 is what times what? 2 times what? Oh, I guess we could put negative 2. Doesn't really matter. Sure. Do that. 2 times what? 162. Okay. So I'll put negative 2 times 162. Fine. We'll move the negative in there. All right. So this negative 2 is good. I can't break it down anymore, but I can break down the 162. What 2 numbers multiply to give you 162? 2 times 81. Yeah. Okay. So then I gotta break this down again. Negative 2 times the 2. 81 breaks down into what times what? 9 times 9. And then guys, the 9s, they each break down into 3 times 3, right?
Negative 3 and 3 under 3, and then you have 2 twos.
So let me see. So I have a negative 2, right? Because I only need just the one negative, right? And I have the 2.
And then you have 4 3s.
Good. 3, 3.
I did a little bit differently.
3. You did the tree.
Well, I did one of the 3s was negative and the next 2 was positive.
Okay, that's fine. But you have only one number that's negative inside, right? Yeah. Okay, good. All right, so guys, are they all prime numbers? Yeah. All right. How many do I need in a group in order to be able to come out? 5. Do I have 5 of the same thing? No, we're so close with the 3s, but we only have 4. We don't have 5. So you know what this means? Nobody comes out. Everybody goes right back in. Okay? So this is one of those weird ones where, all right then, fifth root, nobody can come out, so just let's all just stay in. Negative 324. Okay? It just feels so weird because it's such a big number. I feel like we should be able to bring something out. We can't. Okay?
But I got the x cubed would come out, and then I have in the inside negative 324 x and
All
then
right.
4 y's.
Okay, so then let's look at those together then. All right. So we have, let's look at the x's. We have 16 x's inside. How many groups of 5 can I make? 16 over 5. Well then, this is one where I have to either draw out 16 x's or I need to just do my long division. You should get 3 point something, right? When you divide, yeah? So then, yeah, just like Tom said, 3, that's your outside number. So 3 times 5 gives you 15, and you want to subtract that from your 16, so what's your remainder?
1.
Good. Yeah? So that means 3 x's. So x cubed comes out. How many stay in?
1.
1. Gotcha, Lynn?
Get the range of the y's.
Why not?
Because there's not enough to find for it. So
Good.
all the 4 that you have, they have to stay in.
Perfect. Good. So you see the y's? Y to the 4th. Tom said it. You don't have enough for them to come out because you don't have 5. You only have 4. So they all have to just stay in. So there you go. I know that my x cubed is kind of far, so I can move it over a little bit, but it doesn't matter. The spacing doesn't really matter. Okay? Any questions about this one? All right, so let's go back to our notes, and we're gonna look at the last section there with the table. Okay, and yeah, and the one way is the radical way. Okay, and that's what we've basically been doing. The rth root of x to the p power, that way, simplify the radical. And then the exponential way, so x to the power over root way. Okay? So, alright, so let's try the exponential. I think exponential is a little bit easier, a little bit faster. If you have the square root of 121, x to the 12th, y to the 7th, just take it one piece at a time. So 121. What is the power or the exponent on the 121? What is the power on this?
12.
No, the 12 is on the x.
It's 1.
It's 1. For the number, it's 1. Right? That 12 is way too far. That 12 is connected to the x.
Yeah, I thought it was like by itself, but I thought it would be like automatically to the power 2.
No, for this one, the root. So the power, if you don't have one written there, is 1. But the root, if you don't have one written there, remember we say square root, right? So then that would be 2. Okay? So it's 121 to the 1/2 power. How about the x? What is the power on the x, guys? 12 over, what's the root? 2. And what about the y's? What's the power on the y? 7. What's the root? 2. Okay? Now, your 121 to the 1/2 power, you got to put that in your calculator. If you get a nice, pretty number, use that. If you get a decimal, just leave this. So put that in. Put in 121 to the 1/2 power. Remember how to put it in? You got to put parentheses around the 1/2. this? Okay. Because 121 to the 1/2 power is really saying the square root of 121, right? Square root of 121 is 11. Now look at the x's. Can you simplify 12 over 2? All right, what is 12 divided by 2? 6. Okay, if you can simplify that fraction, write the simplified form. All right? And what about for the y? 7 over 2, can you simplify that? No, then just leave it as 7 over 2. Y to the 7/2 power. And you know what? There you go. That's it for the exponential form. Okay? Pretty good, right? Just leave it as power over root unless you can simplify it. All right, so what about the radical? All right, so we have square root of 121, x to the 12, y to the 7. Okay? So we're going to start with the first, the number. What's the square root of 121? Huh? Square root of 121
Is 11.
is 11. So 11. All right, let's look at the x's now. How many x's?
12.
How many groups of 2 can you get from 12? You have $12. You want to split it among 2 people evenly. Can you? How much money does everyone get?
6.
6, right? X to the 6. Anything left over? No, right? It's an even split. How about the y's? 7 divided by 2?
You can't do it either.
You can't do it even. How much for each?
So you can take 3 lines out.
Yeah. So if you think about this, 1, 2, 3, 4, 5, 6, 7 groups of 2. 1, 2, 3, right? Like if this was money, $7 split amongst you and me, we both get $3, and then how much is left over? $1 left over.
50 cents.
So you, so then you would have 3 groups, and then unfortunately there's 1 left over, so you gotta put 1. I know, but no sense. No sense. You're right. If we wanted to be really fair, we would go into this, change, but no sense.
So I guess it just has to go in the back.
All right. All right. So let's try the next one, guys. I want you to try. Try the exponential way and try the simplifying radicals way. Okay. So we agree on the exponential. Thank you, Abner. So power over root, the 32 to the 1/5 power. Whenever you guys have numbers, put it in the calculator. If you get a nice, pretty, non-decimal number, then write that down. If it turns out to be a decimal, then just leave it. All right? So what about the radical form? Did we all get this for the radical? Yes? No? If you didn't, say something. Yeah? Yeah? All right, good. Perfect. Good job, Tom. All right. Oh, was that the last one? No, there it is. I was like, I know there's one more. All right. So let's look at this one. All right. I want you guys to try this one too, please. Let's try the exponential and let's try the radical. And then we'll look at the problem on the homework. There's only one problem that looks like this on the homework. Okay. Okay? All right, so thank you, Timlin. Thank you, Kevin. Are we okay with this? All right. So go back to your homework sheet and let's look on the back. If you look at number 12, it says write the following in two different ways. This is the exponential and the radical way. So let's try this one. Fourth root. All right, so we want the exponential way and we want the radical way. I want you guys to try this, please. All right, so for number 12 on the homework, the exponential should be that's your first step. You can't leave these fractions because you can simplify them, right? So this should be 3x to the 3 halves, y squared, and z to the 1/4. Do we get this? Yeah? All right. If you didn't, then just say something, okay? I can go over it. All right, so the radical form, the 3. So let's see, if I have 6 x's, group of 4 here, so one group comes out, I have 2 left over inside. Okay. Now the y's, I have 8. I have 2 groups of 4s, so y squared. And then let's see, z. I only have the one z. I can't make a group of 4, so that has to just go inside. And so here's my radical form. Okay? Any questions about this? All right. So what we're doing now is we're going to finish the rest of this worksheet A. Going over all the homework, right? 9, 10, and 11. Number 9. What did you get for number 9? Cube root of -27 squared. You can put that straight into the calculator. Or, you know what's another way you can put this into the calculator? The power over root way. -27 to the, what's the power on this? Power. 2 divided by, what's the root? 3. What do you get? Just down. 9. Good. Let's try number 10. Number 10 is cube root of -64 to the 4th power. Now, what did you get for this? 256, yeah. Those were nice because your calculator did those for you nicely, right? Now, number 11, I told you guys, your calculator's going to give you a decimal. You may have to rewrite this one. 25 to the 2/3 power. Yeah? Okay, if you put this in the calculator, you get a decimal. All right, we don't want that, right? So let's rewrite this as a radical. Power over root. 25. What's the power on the 25? Huh? 2. And what's the root? 3. Okay? So, okay, let's do this. 25 squared means I have how many? How many 25s? 2. right? We have two 25s here. If it's 25 squared, okay? So I'm gonna break it down. 25 times 25. That's what it means to have 25 squared, right? Can I break down each of those 25s?
Yeah.
Yeah, what times what? Huh? 5 times 5. So this one is a 5 times 5, and this one is a 5 times 5. How many do I need in the group to come out?
3.
3. Look at this, I have 3 of the same. So one of those comes out. Do I have any that stay in?
1.
Yeah. So here you go. This is it. Okay? Now, does everyone have worksheet A completed? Okay. Take out your pink assignment sheet.